Professor Monty. Let's talk about absolute value inequalities. So we're assuming A is greater than 0. If A is less than 0, we have other options, special cases we'll look at another time. But if A is greater than 0, we've either got the absolute value of x is less than A or the absolute value of x is greater than A. So let's look at those individually. Remember, the absolute value means the distance. In this case, distance from 0 since x is all by itself. So the distance is less than A units away. So if we think about that, I can go A units to the right, I can go A units to the left, and what that would get me on the number line, that's between negative A and positive A. I can't go more than that. My distance has to be less than A units away. So I can be anywhere between 0 and A this way and 0 and negative A that way. I can be anywhere in there. So graphically it looks like this. Writing that with inequalities, we could write this. We could say either x is between negative A and positive A. And then with interval notation, it looks similarly. We would say, oh, I'm between negative A and A. All right. Let's look at greater than. If it's greater than, I can still go A units to the right, A units to the left. And again, that's negative A and positive A. But now I have to be more than that distance away. So if I'm more than A units, I can be anywhere over here, or I can be anywhere over here. I just can't be in between. And so if we look at that with inequalities, notice the graph is 2 pieces. So when I put the inequalities, that has to be 2 pieces as well. So I could be anywhere from negative infinity to negative A. Let's write it with the inequalities first. Then we'll go to the interval notation. So either x is less than negative A, or x is greater than positive A, right? To the left, less than negative A, or to the right of positive A, greater than A. Interval notation, similarly, it's going to go negative infinity to negative A, union A to infinity. So first off, remember, when I have absolute value less than some positive number, it's going to be a single piece. Inequalities, interval notation, 1 piece. But if it's greater than A, it's further away, it's going to be 2 pieces. Here's the graph, here's the inequalities, here's the interval notation. Let's look at a couple examples, see if we can work through these. So I've got the absolute value of 2x plus 3 is less than 9. Well, it's a less than, so it's this case. I can jump straight to this format and go, oh, if that's the case, the 2x plus 3 has to be between negative 9 and positive 9. And then I can just solve those independently. Remember, it's a compound inequality, so whatever I do to the middle, I have to do to both outsides. I'm solving 2 inequalities at the same time. So I get negative 12 less than 2x less than 6. Divide by 2. I get negative 6 is less than x is less than 3. That's my inequalities. The interval notation is going to say, oh, I'm between negative 6 and 3. That's my answer in interval notation. If you want to go to the graph, you can. But notice what we're saying is, oh, I'm between negative 6 and 3. So it's going to be that sort of picture. All right, let's do another one. Remember, my goal is to get x all by itself. So let's first isolate the absolute value. So I'm going to subtract 5. So I get negative absolute value of x minus 6 less than or equal to negative 1. I don't want that negative. I either multiply or divide by negative 1. It's easier to show division by negative 1 on the board. But remember, anytime I divide by a negative, I have to flip the inequality. So I have the absolute value of x minus 6 is greater than or equal to positive 1. Oh, now I'm in this form where I have a greater than with a positive number over there. We'll just use the equals. But remember, graphically, that means we're from some point here, and it's actually the point is positive 6, I can go 1 unit this way, I can go 1 unit that way, but I have to go more than that. So graphically, it's going to look like this. It's going to be 2 pieces. And if we think about that going to the left, it's a negative 1. So the idea is from this graph, I'm going to say, oh, x minus 6 has to be less than or equal to negative 1, or x minus 6 has to be greater than or equal to positive 1. That's exactly what I did right here. And so I just add 6 and I'm done. Plus 6 plus 6. X is either less than or equal to 5, or plus 6 plus 6. X is greater than or equal to 7. And so I can actually draw those right here since I have those written down. And then that's it. So my interval notation, negative infinity to 5, bracket with the 5, union 7 to infinity. So you may want to go to the pictures when you draw this. That helps me, at least I'm visualizing the pictures. That's how I understand both the inequalities and the interval notation. But make sure they make sense. Anytime you have absolute value is greater than some positive number, it's going to end up being two pieces. Absolute value less, it's going to be one piece. It's going to be in between two numbers. Okay, hope that helps. Practice. This is going to take a little bit of practice. This is confusing to a lot of students, but work with it, stay with it, and you'll get it.